Hello, good afternoon. My name is Jacqueline Torres, and I'm going to be covering a fourth grade science TEK. And the TEK will be on matter and energy. The student knows that matter has measurable physical properties, and those properties determine how matter is classified, changed, and used. The student is expected to measure, compare, and contrast physical properties of matter, including size, mass, volume, states, temperature, magnetism, and the ability to sink or float. My lesson today will be on sheltered English instruction, and let's begin. Okay, students, so today we're going to be covering matter. So everybody on your interactive journal, open up to the next clean page and write a title on top. It's going to say, what's the matter? Okay, so the learning objectives for this lesson will be that you will each know the state of matter in terms of its molecular structure. You will be able to define matter and mass. You will identify some properties of matter, and you will be able to compare the properties of different states of matter. Okay, has everybody finished writing the title on the top? Again, one more time, the title is What's the Matter? Okay, so we're going to begin by learning about solids, liquids, and gases, or the states of matter. Does anybody know what a molecule is? Okay, Maria, can you tell me what a molecule is? Great answer. Okay, how about you, Gabriel? Very good. A molecule is the smallest amount of something. Okay, so let's review one more time. A molecule is the smallest amount of something, and that molecules are so small that they can't even be seen with the eyes. And everything is made up of molecules. You and me are made up of molecules. The desks we're sitting on are molecules. The chairs. What else? Can somebody tell me where else we can find molecules? Correct. In the air around us. In the drinks we had in the morning. The milk, our orange juice. Very, very awesome, you guys. Everybody is doing a fantastic job. Okay, so now in your interactive notebooks, we're going to be taking some notes on matter. So let's begin by drawing a square. It can be a small square or a medium square, as long as it does not cover up the whole page. Okay, so does everybody draw a square? Okay, and on the bottom of it, we are going to label it as a solid. Okay, we're going to label it solid. S-O-L-I-D, solid. Okay, now for a solid, that's one type of matter, the molecules are very close together. So I want you to draw a whole bunch of tiny, tiny circles inside of the square and draw them very close together. I want you to draw a lot of the circles, okay? So keep drawing, a lot of circles, tightly, tightly packed together. Very, very tightly packed. Almost no spaces between the circles. Okay, so your circle should look something like this. They are very close together and don't have much room to move, correct? Okay, so a solid has a definite shape and a definite volume. Okay, so let's go ahead and write that down. Definite shape and definite volume. Definite shape and definite volume. Those are some facts about a solid. Now, can somebody think of and raise your hand and tell me what a solid is around this room? Give me some examples of solids. Take a second to think about it, and then when you have something, raise your hand. Okay, Jennifer, can you tell me a solid that you see around this room? The deaths, very good. Those are solid. They have a definite shape and a definite volume. Okay, somebody else? Sebastian, tell me a solid that you see. The chairs, awesome, yes. Those also have a definite shape and a definite volume. Okay, so let's write those examples down. A desk, a chair. Okay, can everybody write those down in your notebooks? And then go ahead and write down one more example that you can think of that has a definite shape and a definite volume. Okay, so now let's draw another square next to the solid. Okay, and our next state of matter will be liquid. So go ahead and label liquid on the bottom of the square. Okay, so just like this, another square with liquid. Okay, is everybody good? Does anybody have any questions so far? Okay, so now the same as the solid, we're going to draw tiny circles inside of the square. But, one second, we're not going to draw them very close together. There's going to be some space between them. Okay? The molecules in the liquids are close together and can touch each other, but they also have more room to move around. They're not as tight and as close together as in the solid. Okay? So let's draw some circles inside of the square that represent the molecules inside of the liquid. Okay? Is everybody finished drawing the circles inside of the square? So again, this is how it should look like. You can refer back to your solid drawing that had a lot of molecules and not really much space to move. But in the liquid there is more space that the molecules can move around. Okay? Now, let's write some notes, okay? So the molecules can move around. They have more flow and can move around. So flow and move around. Okay. Now let's take a second and think about what liquids we know are this state of matter. Okay. So let me give you an example. The milk we had this morning, that's a liquid. Okay, so go ahead and write that down. Milk, la leche. Very good, Maria, la leche. Okay, and what else? Water. Water is very important. Okay, and go ahead and write down one more example of a liquid that you can think of. Coca-Cola. Very nice. Very nice. Okay. Awesome job. Okay, so as you can see, we have the solid. Can everybody say solid with me? Solid. Very good. And now the liquid. We have drawn the liquid, the second state of matter. Okay, now let's go on to the third state of matter. We're going to draw another square. Okay, and for this time, we're going to label it as a gas. Okay, so here's the square, and we labeled it gas. Okay, now for this one, it's different than the other ones. They are a few circles inside of the square, but they can also be outside of the square, because you can draw it like this. Can anybody take a guess why there's some molecules outside of the square? Okay. How about you, Jackie? Can you give me an example? Okay, no problem. I'll get back to you. Just take a second to think about it and I'll come back to you. How about you, Berta? Can you give me an example or explain why they might be these molecules outside? You think they move outside of the square because they don't have definite shape? Okay, that's very, very good. So the reason that these molecules are outside of the square is because a gas, it moves around everywhere. It's very free, they move very quickly. The molecules want to move, they want to move around. So let's go ahead and write that down. The molecules move around freely and they move very, very quickly. Okay, so move very quickly. Okay, so as you can see on the board, here's my picture, and then I noted down that the molecules move around freely and they move very quickly. Okay, so these molecules, they always move around, they're very fast, they bump into each other and bounce off each other, and they do not stay in the same place unless it's in a container. So for example, the air around us, there's air all around us, and the molecules are moving very, very quickly. But the air that we have in here can also go outside. When we open the door, the air will go outside. When we breathe out, the air that we're breathing out is also not in our bodies, but it's going out, and we are also breathing air in. So again, that's why the air can move all around very, very quickly. So let's go ahead and label that. The air around us, that's a gas. Okay, and can somebody think of an example? Let me give you a clue. The clowns, they like to make different shapes with them. Can somebody give me an example of what you might think those are, where there's gas inside? Balloons, very, very nice. The balloons, although the actual balloon is a solid, there is gas inside of it. Okay, and gas, another example of a gas. How about the hairspray bottles? Those have a lot of gas inside of them, correct? They're sticky gas, but it's still gas. The oxygen, awesome. Who said that? Maria, very, very good job. Oxygen. Oxígeno, awesome. Yes, that's oxygen. Oxygen is oxígeno. Okay, so now students, we can see how we have the three states of matter. There's the solid, the liquid, and the gas. Okay, so everybody should have these pictures, these notes, and these examples written down in your journal to describe. Very, very good job, students. We're going to take a little quick break and just think about what we have gone over, and we'll cover more on the states of matter in just a sec.